When I described calculate, I say that calculate generates an equivalent filter context. So it starts with a raw context and generates an equivalent filter context. The point is, what do I mean by equivalent? The raw context always contains a single row, and that is well known. But does the filter context or the equivalent filter context always contain a single row? Not necessarily. Unfortunately, it does not always contain a single row. It contains all the identical rows. And this is important to remember, because in order to generate the equivalent filter context, DAX generates one filter for all the columns of a table. But in the case where you have identical rows in the same table, you might end up having a filter context that contains multiple rows. And we can see that with a demo on this code. But let's look at the code and then let's look at the code for a second and then we look at the demo. Imagine that I create a measure, total net sales, that is sum x over sales of quantity multiplied by price. It's a very simple expression. And then I want to compute the sales for only the sales where the unit discount is greater than 0. I can write sales wrong by iterating a filter where I filter sales only for the sales where unit discount is greater than 0, and then trusting context transition, instead of rewriting quantity multiplied by price, I invoke it as a measure. And I trust context transition to evaluate that measure row by row. If I compute this value, I will get a wrong result, because this is not filtering an individual row, but might filter multiple rows. We can see that in a demo, and then we will write the correct version of the code.
I just have to open another example.
Okay. Keep in mind that this is, it's not something that will happen to you very frequently. It's something that you need to know and you need to remember, because when you write your code, you might see strange numbers or numbers that do not match your needs. And most of the times, the problem is with context transition or with problems with the propagation of filter context. So in this example, for example, we have sales wrong. Just click on sales wrong. You see, sales wrong is sum x over filter sales where sales amount is greater than 100, and then compute the measure sales amount. Sales amount is quantity multiplied by price. Is an iteration over sales, quantity multiplied by price. But if you write it in this way, you get this number. You might expect the number to be correct, whereas in reality, the number is not correct. Because if you show me sales correct, the correct way of computing it is computing sum x over filter, and then do not rely on context transition. Instead, multiply quantity by price during the iteration. Why that? Because if you do the iteration row by row, and then row by row you compute this expression, you are guaranteed to scan one row at a time. On the other hand, if you use the previous version, sales wrong, this will iterate sales, filter only the rows where sales is greater than 100, and then for each row where the sales are greater than 100, it will invoke the measure. Invoking the measure, it performs context transition, but context transition will not generate a filter context containing one row, but it generates a filter context containing all the rows which are identical to the given row. And if you have duplicates, and duplicates happens very frequently in fact tables, then all those duplicates will be counted many, many times, all the times for each version of the duplicate. And so the numbers you will see are wrong. Basically, you need to know what context transition is, you need to understand what context transition is, and learn how to use it. Now that we explain it, we will make a lot of examples of context transition usage. The point is understanding what it is. It's an extremely useful feature that you need to master in the right way.
Just to clarify this example, we can show that if we have the sales amount measure, we fundamentally iterate all the rows in the sales table. When we just try to call sales amount within another iteration, like in this case, we may suppose that if there was a one-to-one relationship when we translate one row of the sales table into a context transition, this should produce exactly the same value.
Well, it is
but
not.
This is not happening, and we have a higher
easily.
value because probably there are a few rows in this table that have exactly the same value in all the columns. And for this reason, these two rows cannot be recognized, and this is a simple way to check that actually in this table there should be duplicated rows.
Yeah.
If we had a primary key, this shouldn't happen.
If we had a primary key, then duplicates would be gone. But in fact, the problem of context transition doesn't really happen for dimensions, because on dimension, having a primary key, filter context and row context are always the same. The problem is iterating fact tables. Whenever you iterate the fact tables, you might be in trouble. Then this measure is going to be awful also from performance point of view. But apart from that, it's semantically wrong. So it produces a number which makes no sense. Now, let's go back to the slides, because there is one last topic that I want to cover, that is that of circular dependency.